Hi, welcome back. Today we're gonna continue from where we left off in the previous video. In the previous video, we created our first 3D object in Unity, and afterwards I showed you guys how to move our objects in our view, in our scene view. If you remember, I showed you guys how to move our objects like this, for example, or maybe like this. A little bit of this too, up and down. This time we're gonna do the same but with code. I'm gonna show you guys how to create our first script, and then we'll write our first lines of code, and then with said code we're gonna move our object. Let's begin. Now folks, in the previous video we created our first project. Here it is. For now we'll continue with this project instead of creating another project. So let's open our project. I'll see you guys in the editor. Now to start, we need to create a component that can store our lines of code. That component is a script. We need to create a script first. Let's move to the project window of our editor. As I told you before, the project window is where we store all the stuff in our projects. I don't know. Pretty much all the files remain. Let's try that again. The project window is pretty much where we store all the files related to our project. First, let's create a new folder in our assets. Let's call it scripts. The folder is here to keep things organized. For example, in the future we will have a lot of more assets in our project. We will have scripts, materials, objects, prefabs. I'll get into that later. So the folders are there to make sure nothing gets into each other. Now that we have our script folder, we will be adding our script to the folder. Right click on the folder, go on create, and then you will see here mono behavior script. Click on this. And there we go, we created our first C# script. I named my script player behavior, and but you can give it any name you want. Just give your script a name that makes sense. Now that we have our script created and selected, you can see that our script has an inspector window. With the inspector window giving a preview of what's inside the script. Now our script is a component, and because of that we need to assign it to an object for it to move. For it to work. So let's select the cube object that we created in the previous video. And then we will be dragging our script into the cube's inspector window. And just like that, we assign the script to our cube object. Now all we need to do is dig in and start coding. Let's click on the script object and then get in our IDE. In our script, we can see some keywords that may or may not be familiar to you. For example, we are using the Unity engine namespace. Our script is inheriting from the monoBehavior class. And then there are the start and update methods. Now, what these two methods do is the update method runs with each frame, and then there is the start method which runs before the update method runs for the first time. Now, before we start coding, I want to return to the editor and then help you visualize what we're gonna do. We learned in the previous video that when an object moves, their position values change. For example, if the object moves in the x-axis, their x position changes. Moves at the z-axis, and their z position changes. And finally, when they move in the y-axis, their y position value changes. This means that if we want to move our object via code, we need to influence the object's position values via code. And for that, we need to influence our object's transform components. Moving back to Visual Studio, let's try coding. Now, as I said, we need to influence our object's transform component. For that, let's start with simply transform. Now that we are working with our transform components, let's imagine again what we are gonna do. We need to move our object from one position to another. And in order to do that, we need to use a method called translate. The translate method allows us to move our objects alongside the three axes. And in order for the method to work, we need to give it three positional values. One for the x-axis, one for the z, and one for the y. So let's just do that. I will be writing transform position x, and then transform position y, and then finally the same with as z. Now currently what I'm giving to the translate method is our object's current position. So if we run this, nothing's gonna, the object is not gonna move, its position won't change. But we want the object's position to change. So in order to do that, let's do some maths. For example, let's say that we want the object to move alongside the z-axis. For that, we need to do something like this. Right now, what the translate method will do is, while moving the object, it will keep its x position value. The x position value won't change. And just like that, the y position value also won't change. But the z position value will be increased by 1 with every frame because it's in the update method. Now that we wrote our first line of code, let's say I am not sure if it's something I need to say, but you should save regularly while working with your scripts. You should save pretty much religiously after every change. So now that we saved our object, or script, sorry, let's move on to the Unity editor. And we can see that in our scripts inspector window, the preview change, it is now showing the line of code that we just wrote. But I wonder if it's gonna work. So in order to see, let's test it by running the game. And just like that, let's see where our cube object is. Whoa, what the fuck happened? Hold on, that wasn't supposed to happen, hold on. Folks, I messed up, hold on. Oh, the fucking positions. Folks, we need to make sure that our object's position values are completely zero. Because right now they are not completely zero, it's higher than 0. So we need to change that. There you go, 0, 0, 0. Let's try again. Our script is the same, keeping the x in the same value, keeping the y in the same value, but gradually increasing the z value. So let's see if that's gonna work. As you can see, folks, when we start debugging and playing our project, we can see that while our object's x and y value are the same, staying at 0, our object's z value increases very rapidly. I still wasn't expecting it to move so fast though. We need to change that. Folks, we have a problem. Our object is moving too fucking fast. So let's change that. Hopping back onto Visual Studio, let's add a tiny detail to our line of code. Multiply by time dot delta time. Time dot delta time represents the interval between the last frame and the current frame. Let me try to better explain what this adds to our code, to our math. Now we have our x position value, which is 0. It stays as 0. And then we have our y position value, which also stays at 0. And finally we have our z value. We add 1 to it, 1 unit, and then finally we multiply it by time dot delta time, which in my case it's this. So by adding time dot delta time, what we are doing is basically making our movements independent from our frame rate. For example, some equipment, some computers may have a lower FPS, while some computers may have a higher FPS. That would make the movement speed different from computer to computer. Adding time dot delta time prevents that from happening. Let's save our script and try this. Oh, this is a fucking disaster. Look man, I don't know how math works, okay? I'm not good at math. Sorry. I'm not even gonna try explaining. Let's move on. We can also do the same shit, but instead of writing all this, we can do vector 3 dot forward. And let's add time dot delta time as well. Now this will move our objects forward. I don't know, it's forward. It says forward. Instead of that, we can do left, right, and finally back.